So one of my goals I've always had is to transform 3D printed components and cast them into metal. And one of the processes that is involved in doing that is the lost wax method.
Lost wax method, yep. So you need wax to lose. So we're going to use wax for the mould and put a ceramic wax. Nah, man, you're talking rubbish, bro. Keep it simple, bro. Fuck. Now, really, just making a mould out of wax, and then we're going to put a mould around it. That's from refractory stuff that doesn't burn, and it goes hard, turns it into a shell. After melting that wax out, we're going to use that to pour metal in. Nice. And that's going to give us high detail, and that's why we're going to do this method.
Cool. And one of the things we need for that method, for the whole process, is a dewaxing station. And a dewaxing station is more or less an oven turned up to 11. You need it hot, you need to burn out the wax, and you need to have a clean shell left behind. And to do that, unfortunately, you can't use Mum's oven in the kitchen. Well, you could, but you get in a lot of trouble.
Yeah, and then, everything after that will taste a bit funny, eh?
A bit waxy.
Yeah. It'll be memorable.
So, in this video we're going to show you how we built our dewaxing station. We picked up a second-hand metal filing cabinet from Marketplace, which will be used as the main body for the dewaxing station. Any plastic or aluminium components were removed as they will not be able to withstand the intense heat inside the dewaxing station. Two of the metal drawers were upcycled into external heat shields over top of the ring burners, which you'll see later in the video. For our heat source, we are using two LPG ring burners, which are rated for 30,000 BTU output each. However, we will be using a high flow gas regulator, so the BTU output will be even higher than that. To mount the burners, we trimmed the standoffs and tapped threaded holes.
What's that accent that you got there, bro? Oh. That's Rotorua, eh? I'm not from here though. How we speak over where I'm from, we just speak normal like this, eh? But do as you do in Rome, eh?
When in Rome.
Yeah, or in Rotorua, eh?
Then we used a jigsaw with a bimetal blade to cut out holes in the cabinet. We also added a 200mm hole at the top of the cabinet as an exhaust. After mounting the burners to the side of the cabinet, the heat shields were added over top. Solid metal caster wheels were mounted to the cabinet so it can be easily moved anywhere in the workshop. Right, so the bro is going to show us how to make ceramic washers to hold the insulation. How do we make them?
Oh,
Oh, okay.
not like that.
Before the drop, we did an experiment by scoring the terracotta tray with a box cutter in the hopes that at least some of the pieces would break along the score lines. But as can be seen, it wasn't worth the time. We selected various pieces of different sizes and then proceeded to drill 2 holes in each piece. Holes were drilled into the cabinet, which we'll use later to wire tie the insulation to the cabinet walls. Speaking of insulation, it's time to unwrap our Superwool insulation. I'll leave a link and details about the type of insulation we are using in the video's description. In short though, this is nothing like your average glass wool insulation you'd find used in a home. Superwool is a high temperature flame retardant insulation rated for temperatures of up to 1300 C. And unfortunately it's the most expensive component to buy for the build, which cost us roughly 600 New Zealand dollars at the time of filming. The fibres of the insulation can be an irritant, so gloves, goggles, dust mask and long sleeve shirts were worn while we cut and fit the insulation. With the insulation cut to size, tie wire was poked through the side of the cabinet and a piece of ceramic was used as a washer to support the insulation. And I would imagine, looking at this insulation, it appears quite soft and compressible, so you probably don't want to compress it to oblivion. Is that right?
Yeah, it's quite crushable, yeah.
Yeah. Following a short burn test, we decided to enclose the ring burners with insulation to prevent the flames from burning the sides of the cabinet. With that done, we upcycled an old barbecue grill plate as a platform to sit our moulds on. As the wax melts out of the mould, it can fall through the grate and into a tray, which we'll make next. I used some thin sheet steel and folded it into a tray to catch the wax. Well, that sounded like a door at the bottom of a dungeon or something.
Sounds like a tenant going under.
This is true. And with that done, we finished off the cabinet by adding a sheet steel door to the front. Now I can plumb in the burners to a barbecue gas bottle regulator. A little something something like that, and then he comes over here and then we're all gassed up. What do you reckon? Yep. Ooh.
That's me trying to speak with my mouth closed.
To ignite the burners, I'm using a handheld blowtorch. We drilled out a pilot hole at the rear of the cabinet so we can insert the torch and safely ignite the burner without any risk of flashback.
Is it ready?
Yep. It just shut off. Hey? So viewers, this regulator is faulty. It's only getting to like 5 psi and then just shutting itself off. Boo! Don't like it, so we're swapping out to another one we have. As it turns out, the regulator we used was not faulty. Rather, this particular regulator has a rather annoying safety feature which limits gas flow, which might be great for barbecues but doesn't work in our application. So with a new unrestricted regulator, let's go for round 2. This time we were successful. However, we did have one slight issue. Hot gas was escaping between the top of the door and the cabinet, and as the metal door heated up, the situation was made worse as the intense heat would warp the door, making the gap even larger. We're just tempering the steel. Fortunately, this was easy to fix by adding some steel box section to the top of the cabinet, which would make contact with the insulation on the door when the door shuts. Once again, we fired up the burners, and this time there was little to no warping of the door. In broad daylight, it's difficult to see just how impressive the flames are, so we waited until nightfall to take some more shots.
That's cool.
When the door is shut, the flames make a vortex inside the cabinet, which is ideal for even heat distribution. With that done, it's time to move on to dewaxing a mould we prepared earlier.
We've got a new edition of a butane torch. The purpose of that is to hit the cup, and the other two burners are going to melt the wax from the other different areas within. So we've got an even disbursement of heat. And the fact that you see it poking out, this is where the majority of the heat exhaust is coming out, so we're utilising that heat exchange in order to get the wax from the top as well. Everything is well insulated, so we're going to be relatively safe due to my lack of safety gear. We do have face shields and gloves as well, so that we're not burning ourselves. With all our safety measures taken in place, let's go. So if you heard a thump there, what that was the rebar that's in the middle of it dropping out. That means that the wax is flowing out at a rapid pace. The carbon that you see is the wax burning off. We're going to wait till the top there is white again, then we know that all the wax is going to be out. That's amazing. If you've never done ceramic casting before, this is awesome. Because it's all in one piece, nothing's cracked, nothing's broken. It gets so hot in there that it vaporizes the wax. Everything is still intact. I don't think anyone should complain about the success that's happened. You now know the effect that fire has on a barbecue. But the reason why is no one's ever going to have a 1500 degree cooked steak.
Oh, but think of the crust on the steak though.
Crust. The steak will be crust. Oh, they'll see that in the video anyway.
Yeah.
Yeah.
Do you want it on the table? No.
Nah. That's ugly.
Wow, I'm glad you said it.
I'm like, what is that? You get all these comments. What is that?
It's a headless gummy baby.
What we actually cast in is lollies. Big lollies. Big mouldy lollies. What's a mouldy? Oh, it's not like something with mould. It's actually a race in New Zealand, you know. It's the indigenous people. If you don't know. There you go, you know now.
Better living, everybody. So, after our first successful de-waxing, how do you feel that went? That would be a good question to ask, wouldn't it?
Incredible success. Wax removal was fast. Refractory ceramic shell was cooked to perfection, and the temperatures were amazing. So amazing. That used to be flat, but now it can be the grill for your granddad's old truck.
What do we need to do to further refine the design?
To further refine the design, we need to improve our grate. We need to also prevent the door warping, and where the wax is coming out, we need to have a better solution for the evacuation of that wax, because it vaporized. It was so hot.
There's not even residue left in the bottom of that pan. It is just gone. And the point of getting rid of the wax from the furnace is so that you've got less soot, you've got less smoke, and that's kind of something your neighbours are going to appreciate. Or if the workshop you have doesn't have good ventilation, you want less smoke. It's just good.
Yeah. We are not associated with Snoop Dogg, so less smoke is better. Oh, jokes! Who says that one?
But I mean, heck, for a first episode, what a success!
Yeah. By the way, love you, Snoop.
Next thing, Snoop's on the phone. Excuse me, you have a problem with my smoking?
Ace! Bro, you wanna come on our show? Bro, come out. Yeah, I know you've been here before. You know, I got cousins, bro.
Yep.
Wink, wink, nudge, nudge. Nah, it wasn't me.
If you're interested in watching more episodes just like this, and how this project develops over time, you know where that subscribe button is. Thank you for watching, and we'll see you in the next video.
See you, bro.